In this next chapter, we're going to be talking about conformational isomers. Conformational isomers result from the rotation of sigma bonds, and it can result in different energies for these different conformations. We've already said that sigma bonds can rotate, but that rotation is not energetically free. In other words, some of the angles of rotation are more energetic than others. Okay, so let's just take a look at this. This is ethane, a molecular model of ethane. And if we look down the axis of ethane, we can see that the top hydrogens can exist in what's called the staggered configuration, or they can be eclipsed. So when they're eclipsed, they are interacting with each other in a more energetic way, and so it's less stable. So what we find is ethane exists primarily in the staggered configuration. Now we need, in order to discuss conformations, we need a way so that we can draw this on a flat piece of paper. And so right now we're going to introduce what's called a Newman projection. So to draw a Newman projection, we draw a dot, which is the top carbon. So that's this carbon right here. And then we draw a circle, and that represents the back carbon, which is back here. And then we show the angles of the substituents that are coming off of those. So for this front carbon, I've got 3 hydrogens coming off in these directions. And then on the back carbon, I have hydrogens coming off in those directions. So this shows the Newman projection for staggered ethane. Let's real quickly draw the Newman projection for eclipsed ethane. So for eclipsed ethane, we draw the front carbon and the back carbon. And so we can draw the Newman projection for eclipsed ethane. So now I want to look at butane, and we're going to look down this bond axis right here, that carbon-carbon bond axis, C2 to C3 bond axis. We're going to look down that bond. So if I put a dot showing the C2, I've got 3 things coming off of that. I've got a methyl group and 2 hydrogens. And then for the back carbon, the C3 carbon, I've got 2 hydrogens and a methyl group. But not all configurations are equivalent. The one that I want to point your attention to right now is the so-called gauche configuration. In the gauche configuration, the methyl groups are adjacent to one another, but they're not eclipsed. So this is a staggered configuration where the methyl groups are as close as they can be in a staggered configuration. It's called the gauche configuration. So with butane, there are actually 2 staggered configurations. One of them is called anti, and the other is called gauche.